Okay, we have a look at a question with bungee jump. Alright, so you are supposed to fill in where the GP is maximum, GP is minimum, and so on and so forth. Alright, so GP maximum is very easy, it's at the highest point, obviously. Okay, GP minimum obviously is at the lowest point. Okay, KE is 0, 0.1 because I'm at rest. Okay, 0.5 I'm also at rest. Okay, because I'm at the lowest point, it means that my velocity change direction at this point. Okay, where is KE maximum? Okay, this is actually the hard part of the question. I'll come to it in a moment. Okay, where is EPE 0? Okay, when is the elastic potential energy 0? Okay, the elastic potential energy is 0 as long as the cord did not stretch. Alright, so at 0.1 is not stretched, at 0.2 is not stretched, at 0.3 is starting to stretch. So if at 0.3 we take it that the cord has not started to stretch, alright, we say that at 0.3 also the EPE is 0. Alright, so these three positions the EPE is 0 because there's no stretching. Okay, where is EPE maximum? Very clearly is 0.5 because this is at maximum stretch length. Alright, so now we come back to 0.4, which is the point that is difficult. Where is KE maximum? Okay, it's very clear from part 1 to position 1 to position 3 that throughout this motion KE increase simply because there's only a exchange between GPE and KE, right? I lose GPE, so I must gain KE, right? This part is simple enough. Okay, but from 3 onwards is not so clear because there is interaction between 3 energies right now. Okay, so from 3 to 4, I know I lose GPE. I know that I gain EPE because the rope starts to stretch. Okay, but what about KE? I'm actually not very sure, simply because I don't know the magnitude of the loss in GPE and the magnitude of gain in EPE. Okay, so my KE is actually pretty unclear. Okay, so one way we can look at how whether or not KE increase or decrease from 3 to 4 is by looking at the free body. Okay, if we look at the free body diagram of the man at 0.3, okay, it's a point at which where weight obviously acts on the man. Okay, the other force acting on the man that starts to increase as I go from 0.3 to 0.4 is the tension in the rope. Okay, and tension is obviously outwards. Okay, from the position 3 to 4, I know that the tension is always smaller than the weight because at position 4 I'm at equilibrium. This means that at position 4 my tension is equal to the weight. So before position 4 my tension must be smaller than the weight because there is less stretching of the rope. Okay, so I conclude that from 3 to 4 my net force acts downwards. Okay, because mg is greater than the kx. Alright, if my net force is down, my acceleration is down. And since my original velocity at 0.3 to 4 is down, okay, the acceleration and velocity in the same direction means I'm speeding up. So this velocity vector gets bigger and I know my KE increase. Okay, so at 0.4 we know that this kx become as big as the mg. Alright, so what happens from 0.4 to 0.5? You should know that kx start to increase more and more because the extension increases more and more. So from 0.4 to 5, what happens is actually the tension is greater than mg, hence my F net is upwards instead. Okay, as opposed to 3 to 4 where the F net is downwards, my acceleration is hence upwards and my velocity is still downwards. Okay, so we conclude that since acceleration and velocity are in opposite direction, from 4 to 5 I must be slowing down, hence my KE drops. Okay, so this concludes, this gives me the conclusion that 0.4 is the point of maximum KE because from 1 to 3 I'm increasing, from 3 to 4 I'm also increasing, right? From the free body diagram I can tell that my KE is still increasing. From 4 to 5 I start to decrease. So the highest KE must be at 0.4. Okay, the final part of the question, after oscillating up and down, okay, losing energy, when does it come to rest? Okay, I come to rest at 0.4 because 0.4 is the point at which there's no